Hi there, Serdar Yegodlov here for InfoWorld at IDG. In this episode of Smart Python, we're going to look at the basics of Python's type hinting syntax and what it can do to make your code better and more readable. Now, Python's always been dynamic but strongly typed as a language. And what this means is that variables in Python don't have strong types, but the underlying objects associated with those variables do have types. Here's what I mean by this. When we create a variable in Python, we're creating a name in a namespace. In this particular case, it's in the global namespace for this module, and we're associating that name with some object. So if we say x equals hello world, we're creating the string hello world and pointing the name x at that object. The string object itself, the thing x points to, is strongly typed. We can't concatenate it with an integer, for instance. That won't work. We would have to explicitly convert the string to an integer to perform such an operation, and that would result in a whole new object with a wholly separate type. Plus, you tell me how we're supposed to convert hello world into an integer. But again, x itself, the name that we associate with this string object, does not itself have a type, at least not by default. Now, what's happened in recent versions of Python is that it has become possible to add type annotations or type hints to names in Python. For instance, in this example, if we wanted to indicate that anything associated with the name hello message should be a string, we would use this syntax: hello message :string equals hello world, or just hello message :string. And likewise, we can use the same syntax to type hint an integer variable. Now, it's important to understand what exactly this annotation does. It does not enforce types at runtime. It provides an additional layer of annotation that can be confirmed by a linter or ahead-of-time type-checking system to ensure that the variable in question is used consistently throughout a codebase. Now, here in Microsoft Visual Studio Code, which I use for most, if not all, of my Pythoning, I have the Pywrite type checker and linter installed and configured to work with this project. In this file here, I have two variables, one of them type hinted as an integer, and the other type hinted as a string. Now I'm going to uncomment this section of code, which contains variable redefinitions that go against the type hints that we provided. As you can see, the linter complains about them, and it gives us detailed feedback about what it was expecting and what it got. If we recomment that section and uncomment this section, which has correct types, the complaint goes away. Sometimes we will need to make more complex annotations. For instance, let's say we want to indicate what sorts of objects are inside a container. Here's an example of this, and this uses annotations that are taken from Python's typing module, which is provided for these kinds of more elaborate scenarios. We have a dictionary, where the keys are integers and the values are strings, and we want to annotate that dictionary as such in our codebase. So we use this syntax here. We use the dict type hint followed by a list of integer and string. And this is a way to tell the linter that we're creating a dictionary with integer and string used as the keys and values, respectively. Now below that, we have a function, which is also annotated. The function parameter user_id is an integer, so we have that annotated with an int. And the arrow syntax that you see after the function signature indicates what type of object the function returns. In this case, it's a string. Wherever we call the function, we can get hints as to what types are expected and what types will be returned from it. Now again, none of this is enforced at runtime. When Python programs are compiled into bytecode and run, these type hints are all erased, and they're not used by the Python runtime itself. But the more annotations you have in your codebase, the better the linter or type checker that you're using will be able to check ahead of time for possible issues with types. One other advantage of Python's type annotation system is that it's optional and gradual. If you just want to throw together a one-file script, like this one, chances are you don't need annotations, and the type checker will make open-ended assumptions about what types are in use. But if you're putting together a larger and more complex piece of software, especially something used by other people, adding types throughout is going to be a massive boon for readability and usability. In future videos, I'm going to explore more deeply the way type hinting can work, such as how to hint for more complex scenarios, such as optional variables or other scenarios involving object containers. So that's it for this video. If you liked it, please leave a comment below. Don't forget to subscribe to the IDG Tech Talk channel on YouTube. And for more SmitePython and more Dev with Serdar, be sure to follow me on Facebook, YouTube, and Infoworld.com.